Welcome back to the Sage Audio channel. Today we'll discuss how to master loud and clear without sounding harsh. We'll cover some techniques that you can use to make louder masters that still retain their clarity. We'll also discuss particular topics and concepts that, when understood, will help you think of new and related ways to retain clarity in your master when mastering loudly. Additionally, we'll listen to examples throughout the video. So if you could, like, subscribe to the channel, and stick around for the full video. But first, if you're an artist, engineer, or producer, and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample. All you have to do is set up an account, upload the song, and we do the rest. Up first, let's talk about how look ahead and oversampling reduce harshness when mastering loudly. Pushing the signal into a brick wall ceiling is a quick and effective way to make a master loud. However, it's also a quick way to create intersample peaking distortion and subsequent aliasing distortion. Now let's start by looking at intersample peaking. If you push a limiter hard enough, you may still not see any distortion on your channel meters. However, the level may be so consistently loud that it's going above the maximum amplitude set by the bit depth and sampling rate. Now, although we typically think of bit depth as determining the amplitude of a quantized signal, sampling rate can also help or hinder the accuracy with which bits of the signal are encoded. A lower sampling rate will result in less accurate encoding and subsequent distortion. With that in mind, if we increase the oversampling of our limiter, we can reduce intersample peaking distortion. Additionally, if we increase the look ahead of a limiter, we give it more time to process the signal, resulting in less unwanted clipping. Now, if these don't do the trick, try true peak limiting, but this might reduce the impact of your transients. Another thing to consider is aliasing distortion. If the sample rate of our session is low enough, say 44.1 kHz, then clipping distortion and other forms of distortion may exceed the frequency limitations of what our sampling rate allows for. When this happens, the signal that exceeds this limitation will be reflected down the frequency spectrum as aliasing distortion, which almost always has an unpleasant and harsh sound. Introducing oversampling solves this problem as well, allowing you to push the signal a little louder without unwanted harshness. Let's take a listen to it.
Watch me, caught up in the light, I'm falling, tripping to the night, I'm all in, drifting in your tide, we're flawless. This feeling is swift like a river running through you. It made me go.
Next, let's talk about how low-level compression and transient shaping cause perceived loudness and clarity. It's pretty common for mastering engineers to use downward compression in order to eventually make a signal louder. The idea being, if dynamics are controlled, then the signal's overall amplitude can be increased without clipping. But there might be a better way to achieve a louder master than this method. If you use low-level compression or upward compression, you can take quieter aspects of the signal, capture them, and amplify them, all while keeping the peaks of the signal at the same level. This means that the detail of the signal is pushed forward, making the overall signal sound louder, but without the artifacts created from downward compression. After introducing low-level compression, we'll have a less dynamic mix or master, but one without truncated transients or peaks. We can make these transients even more distinct by using transient shaping. Transient shaping is like a special form of expansion in which only the peaks of the signal are captured and expanded. This makes it perfect for increasing the clarity of snares, kicks, and other instruments with a quick transient. By introducing transient shaping, after low-level compression, we make the signal loud, but with its transient detail intact. Let's take a listen to it.
up in the light, I'm falling. Tripping to the night, I'm all in. Drifting in your tide, we're flawless. I didn't ever think about it all night. Really took it that you want to know. This feeling is swift like a river running through you. And make me go.
Last up, let's talk about how setting the right limiter release is crucial for reducing harshness. When we think about frequencies, we often think about them as how they sound, which makes perfect sense. But we also need to conceptualize frequencies as things that take up physical space and travel through time. Now, I'll get to the part about compression and release times in a moment, but let's consider and understand this concept first. By definition, a frequency is a particular wavelength. More specifically, a frequency is a wavelength as it results to 1 second of time. For example, 1 hertz is a sound wave with 1 complete oscillation per 1 second of time. 20 hertz is a sound wave with 20 complete oscillations per 1 second of time, and so on. Now, this means that each frequency takes a specific amount of time to travel. So let's look again at a 20 hertz wave. If a 20 hertz wave has 20 oscillations in 1 second, how long is each oscillation? Well, if we take 1 divided by 20, we get 0.05 seconds. If we multiply that number by 1,000, we get that time in milliseconds. So it takes a 20 hertz wave 50 milliseconds to oscillate fully. The higher the frequency or pitch, the quicker it travels. So a 200 hertz wave completes 1 oscillation in 5 milliseconds. So what does this have to do with the release time of a limiter? Well, if we set the release time of a limiter too short, it can drastically alter the amplitude of our signal in the middle of a waveform, in turn causing distortion. So if our release time is 10 milliseconds, but we have 20 hertz waves in our master, odds are some of those waves are going to get distorted. With that in mind, we need to set a longer release time than 50 milliseconds. However, if we set our release time too long, then the limiter will continue to attenuate the signal for too significant of an amount of time. When this happens, transients and peaks that are unrelated to the peak, which triggered the limiter to begin with, will be compressed, resulting in a lack of definition and detail. So, to sum this up, if we set our release time to at least 50 milliseconds, we know that every frequency that's within the range of human hearing will be able to pass without being distorted. But we need to make sure we don't set that release time too long. Lastly, the same concept applies to attack times, but if you see an attack function on a limiter, odds are it's the amount of time before the release begins. Let's take a listen to it.
Watch me, caught up in the light, I'm falling. Tripping to the night, I'm all in. Drifting in your tide, we're flawless.
So, these are our thoughts on how to master loud and clear without sounding harsh, but what do you think? Are there some additional techniques that you can think of? Let us know in the comment section below. Also, if you're an artist or an engineer, send us one of your mixes at sageaudio.com. We'll master it for you and send you a free mastered sample of it, All you have to do is set up an account, upload the song, and we'll do the rest. But thank you so much for watching. We really hope you enjoyed it. If you did, please like and share this video with your friends. This way we know that you'd like to see more videos like this one. Also, you can subscribe to the channel. We release 3 to 4 new videos every week, and subscribing is the best way to stay up to date. There's a comment section where you can leave your thoughts on this video, or you can make a suggestion for a future video. And again, if you're an artist or an engineer, and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample. Thank you so much for watching. We'll see you in the next video.